Alright, so in this video we're going to look at how you would index Sentinel L2A cogs in OpenDataCube on AWS EC2. So the problem we're trying to solve is that suppose you want to analyze large scale satellite data, and the traditional approach would be you would download the data from any of the websites. Say if you want to download Sentinel-2, you would go to Sentinel Hub or maybe ESA's website and then download it, then pre-process it scene by scene, and then perform analysis on top of that and give it to client. So you can imagine that it would take a lot of time to do all of that. So instead, now there is a new approach in which what you would do is your analysis part, the processing part is already done by someone else. Say in this case, Sentinel L2A cogs, which is cloud optimized geotips, are present on AWS, and it is processed by Element84 and hosted on AWS. So it is available for free, and you can actually download the data entirely, which is analysis ready. So the entire first half of your traditional approach is handled by, say, AWS, and then the only part you have to do is analysis. Now, but there is another interesting thing is when you download large amount of data, you have to manage as well. So that is where OpenDataCube comes into picture, which is that OpenDataCube is a geospatial data management and analysis platform. So basically what it does is, instead of your traditional scene based pre-processing or analysis, it does pixel based analysis. That is why it is called DataCube. You can imagine in your head what a data cube means now, and it is actually made for this kind of workload, which is a large amount of satellite data. These open data cubes are already in production. You can look out for Digital Earth Australia and Digital Earth Africa, which are two online portals where you can go and analyze large amount of data for those countries. Alright, so the next step is what is indexing. So just to give an idea, indexing is just like you're storing data in a database, but only more efficiently and nothing else. So just as a side note, you should know that PostgreSQL is being used in OpenDataCube as a database. Alright, so this leads us to our topic for this video, is that you want to set up OpenDataCube on Amazon EC2. The machine we would take is Ubuntu server, which will make us feel like we are doing real world analysis or setting up OpenDataCube on real world example. Also to note that we would be using Spatiotemporal Asset Catalog API, that is Stack API here, to index our data. So Stack basically is a specification which allows us to describe our data set in space and time. So traditionally what you used to do is, if you go to Modis and you want to download some Modis dataset, and they would go to their website, look up for their API, then download the data, then go for Landsat. You would also have a different API for that, same for Sentinel. So Stack essentially solves that problem. It gives you like one JSON document, which in similar format, which you can describe all your data sets. So suppose for in this example we are doing Sentinel 2 dataset. So Sentinel has a stack catalog, or which I can show you right here. So this is a Sentinel 2 L2A cogs stack API. So as you can see, this API, you don't have to worry about collections and all these. So what it essentially does is, it is a way to index your data. It is a way to describe essentially every element of your data. Here you can see that this is a collection in the sense Sentinel-2 collection. We are searching for this, and then in items we are looking for, item is basically the scene itself. In this case we are looking at this scene, and then you have assets in that. There are many bands described here. So you can learn more about Stack on their, if you just go to stackindex.org, you would learn more about them. Alright, so this basically covers all the introduction. Now we can go ahead and set up EC2 So I'm on my EC2 dashboard. Let us go ahead and launch an instance. So we will be choosing Ubuntu 22, 24, which is under free tier limit, and this will be sufficient for setting up the initial database. You can scale up later, but I think this will be fine. So you don't have to worry about any of these, just review and launch. You can just check if your setting is appropriate. So we are taking only one free tier micro, T2 micro, and we are opening the port 22. Later we would need to open another port for our Postgres database, but other than that we just have 8 GB of storage and no tags, so we can just go and launch ahead. So I have existing pair, this should load, yes I have, and then we can launch an instance. This might take a couple of minutes to launch, so once this is ready we'll come back and join. Okay, so our instance is now running. You can see here, if you click on this, we have public IP and private IP as well. Let us rename it. You can rename it as Open Data Cube and save it. So let us connect to it. So to connect, go to your SSH client and then just copy this entire thing. Make sure you already have your PEM file. In my case I already have. I can just directly use it. Open your terminal. So I have my terminal open. Here I can directly paste it, but this won't work. Let us see. We need to give sudo permissions, I think so. Yeah. So let us give sudo permissions, and then login. So as you can see, now we are logged in as Ubuntu user. So now we have to set up our database. So the first thing is we can go to the website, Open Data Cube website, and look for the documentation. Here you would see install. Let us go to the page and then see the install process. This is not what I wanted. Okay, you have to go to Open Data Cube, read the docs. Here you would find how to manage an Open Data Cube. Let us click on that, and we are just going to follow the entire step what it recommends for Ubuntu. So the first step it says is you have to install required libraries, but before that it is a best practice to just do an update. If you just do sudo apt update, apt-get update, so that all your apt-get, repository, upstream repository is updated, and most of the times when you don't do it, you won't find these libraries. So it is best practice to first do it, and then additionally you can also do sudo apt-get upgrade. If you're doing on a production environment, it is best to have patches, the latest patches installed. So basically let us see what steps you're going to do. So we're just going to install some GDAL, SDF5, these libraries, and then we're going to install Postgres, and then we would install Anaconda. We won't install Anaconda, but would install Miniconda. Because of the space limitation that we have, we only have 8 GB. I tried with Anaconda, but at some point it failed because there was no space, and when I tried with Miniconda it worked fine. So maybe we'll install Miniconda and then go ahead with all this process. Now let us go to the top, copy this, install the required libraries. Okay, so this is done. Currently you can see there is nothing here. We'll install all the libraries. Just say yes. You would install 700 megs of libraries. Okay, so now this is done. Now once the libraries are installed, now we can go ahead and install Postgres 12. You can also install Postgres 14, maybe whichever is latest and stable, but this worked fine, so I'm just going ahead with 12. can click yes and let this also install. Okay, so Postgres is installed. Our next step is to install PostGIS. If you're doing some spatial analysis, that is better to do it. Let's install that as well. Okay, that is installed. So once PostGIS is also installed, we can go ahead and we can go ahead and check the status if it is running or not. We can do by sudo service PostgreSQL status. So it says that it is active, that means it is running. If it is not running, you can just do, instead of status, you can start. That will also work. Okay, so now next step is according to the documentation. So these are some optional libraries that you can install. In this case, it is not required to just index. So next, it is asking us to install Anaconda. So if we currently type this, it won't work because we don't have Anaconda installed. You can go ahead and install Miniconda. So I would just do wget and enter. So you can see it is downloaded. Now we can just type bash Miniconda and run it. Then it would ask you to read the licensing part. You're not interested, then you can click yes, then click enter. So Miniconda will install now. Again, it might take some time. And Miniconda is installed. We say yes. So Miniconda is installed. For changes to take effect, you have to log out. You can log out and then log in. Alright, so Conda is now active. If you type Conda, you can see. Now we would create an environment. It's called ODC env and install Python and DataCube. This might take time because DataCube has a lot of libraries which it uses internally. Okay, so it gives us error that Conda Forge is not available. I think that is the issue. I might have not read it properly, so you have to install the channels as well. So just do that. So once this is done, now go ahead and install DataCube and Python. Okay, so the environment is created. Now we are just one step closer to indexing our data. We can go ahead and activate our data environment. Let me zoom in. So our environment is active now. Now we can actually type DataCube and then start the indexing, but before that we just have to create a database to store the data. So to create a database, we need to have privileges to create the database. So by default, when you install Postgres, a role is created for you by default, which is called Postgres. So we have to log in to that role and then create a database. So to do that, what we do is we do sudo, we do -i, we do -u. The user is Postgres, and then you can either click enter. So let us click enter here. So now you see the user has changed, and now you can type PSQL. PSQL is the command line interface for Postgres. If you type, you are into that. So it directly went into Postgres without asking for a database, because by default Postgres also creates a database named Postgres. So that is all cool. Now we can either create database here as well, or we can exit here, and from the user we can create DB and name it DataCube as the document suggests. So our database is created. Now we can actually log in with database DataCube. Okay, so our database is created now. Let us see all the users we have. You can see that we only have Postgres users. This is fine. Document also suggests you to create a username with a Unix username you have. Maybe in our case it is Ubuntu. We can create that. It's not required as such. At least in this tutorial, it's not required. So you can exit now using command Q, and exit this as well. You can just click log out, and so everything is set up now. So just to confirm that everything is ready fine, we can actually do sudo reboot and restart, because we haven't done it after installing all the libraries as well. So it is best practice to reboot your system once you've installed many libraries. So let's click enter. So we are out of the remote machine, and once the system reboots we can again log in. Okay, so it has been 2 minutes since I've rebooted. Let us now again log in, try it, log in. Okay, so it is working fine. Now you can see that our memory usage is already 75%. That is why I was telling that Anaconda does not work, Anaconda works. Okay, so now let us activate ODC env. So to index the data, first thing that document recommends, let us see the document. Okay, one second. Let us go to the, see, in database setup we have done everything like this. So we have created database. Oh yes, so we have to do this part, which is creating this file. So you can just copy this file and open your browser and then do nano paste, and then you can paste the entire thing. We have to modify a lot of these things. So let us go to the top. So index driver, database, nothing you have to change. Host name we have to, currently we'll do it localhost, but once our database is set up and is indexed, we can change the IP to our public IP. To our username is Postgres, and we haven't really set the password. That one thing document recommends you do, and I think it is best to do that now itself. So let us give our password as something interesting, open data cube, so that can be referenced when you give the password. So we'll see how to give password just now. So everything else can be left as default. Alright, so once this is done, now we can actually go ahead and do sudo -i -u Postgres. Here we can type PSQL. So a Postgres user is logged in. You can type password here and click enter. So it asks us new password. We can give the new password whatever we desire. Currently we have So once this is done, I've set to the password to open data cube as well. We can log out. Alright, so once this is done, the next step is to find the catalog. So if you go to the documentation, it says that you have to data cube -v system init. So let us first complete this and see if we get any error. So it says that there's some just warning, and this warning I've read about this. It's nothing to worry about for us. If you want to know about the warning, you can go here. Alright, so I think it is created, and it has also created few schemas. So if we go back to Postgres, and type data cube, you would see that there are few users, few new roles added, AGDC. So these users will ingest the data. Alright, so now the next step is to find the product that we are going to index. So ODC already has a document, a YAML file created for us. You just have to search it online. If we go to, I think we can just search Sentinel to L2A. I think DataCube dataset config. I think I've already searched it. Yeah, so in this you would find this product. So we have to download here. So we can go to dataset, and inside products you would find the description of the product. This is not stack. This is just telling the data cube how to set up or how to add the product, which product to add. So these are, we can click on raw and download it first. Just download it. It's downloaded. ls, if you do, you already see it. You can actually remove Miniconda now, it's not required. To ls. Alright, so now this is done. We can now add the product. The first step to add a product is just type DataCube product add, I think, and then specify the product you want to add. Add a product, it says done. Don't worry about the warning. Okay, so now once we have added the product, what it says is, if we go to the index page, here you would see that it asks, so because we are using S3, because all our data is stored in S3, it asks us to install this library. You can go ahead and do that. So basically what it does is it installs some additional packages like Boto3 and Stack implementation in Python, which is PyGeo API, PyStack client, yes. So it's installed those two libraries for us. PyStack is basically to interact with Stack API, and Boto is for S3. Okay, so once this is done, the last step is now to index. So we paste this command. So in this command, stack to DC is the command line tool which was installed when you installed additional packages in ODC. So what it does is it converts your stack document to into DataCube. The stack is generated from the catalogs and other various parameters. So catalog href is the endpoint of the API. Thanks to element 84, it is available for free. And then you have bbox, so you are now defining the region you want your items. So bbox, you are taking 10 degree by 10 degree bounding box. Also collection is Sentinel L2A, this collection you want to index, and the date time is, we are specifying 3 months of 2022. So once we do this, then stack endpoint has a search API. I think it searches based on these additional parameters and returns a JSON document, and then that JSON document is indexed to data frame. It converts. So when we click enter, we can see that it is being indexed from the Stack API. So it might take some time. Let us wait. So here you see that our data set is being indexed. As you can see, there are many metadata stack JSON files that are being indexed. It is not the actual scene, it is the metadata of the scene that is being indexed. So there are many items in the catalog, in the collection of Sentinel-2 L2A cogs in this region at this date time that we are trying to index. Alright, so this ends the indexing part. So if you go ahead and look at the database now, you would have many items inside that. Let us go. Let us type Postgres, PSQL. You want to go to DataCube. If you see, currently these are the roles, and here you won't find any relations because currently it is using public schema. So we have to specify the schema here. There is another schema called AGDC, I think. Yeah. So you see, in AGDC schema, don't forget to add the dot. This shows all the tables in this schema. So you find that there are 4 tables here: dataset table, location, source, and metadata type. And if you query any of these, you find that there are so many rows. And now the only final step would be to open the port 5432, which is the default port Postgres, and that port you can access by any client, maybe by pgadmin, to do your analysis, or without logging into your machine. Okay, So that is it for this video. Maybe in next video I'll show how to open the port for Postgres and then log into your pgadmin and query.